All right, let's look at the homework 3.3, problem number 3. All right, so we want to find the open intervals on which the graph of this given function is concave upward or concave downward. All right, so let's do that. All right, so I'm going to take the derivative using a quotient rule. So we have f prime of x is equal to, right, so let's take care of the denominator first. So we can just square the denominator. So quantity x squared minus 4 squared, right? And the derivative of the numerator is 2x times the denominator is x squared minus 4 minus numerator is x squared plus 4 times derivative of the denominator is 2x. Alright, so let's see, 2x is in common, so I'm going to factor out the 2x. So you have a 2x is pulled out. Then what's left is, so we took care of this 2x here and that 2x there. So we have x squared minus 4. So let's put that x squared minus 4. Then we have minus x squared and minus 4. Alright, so we have a minus x squared minus 4. Alright, all over we have x squared minus 4 squared. Alright, so we can cancel x squared minus x squared. So you have a negative 8 there, so we can combine it. So we have negative 8 times 2 is 16x over quantity x squared minus 4 squared. Right? So that's the first derivative. Right? So let's take the second derivative because we have to talk about concavity. So f double prime of x is equal to, right, another quotient rule. Before that, actually, I'm going to pull out the negative 16 outside first, right? Square the denominator, so we have x squared minus 4 to the 4th power, right? Derivative of the top is x times the bottom is x squared minus 4 squared minus top is x times derivative of the bottom. So to put 2 in front, keep x squared minus 4 and subtract 1 from the power, so it's the first power, but multiply by derivative inside, so chain rule 2x. Alright, so we have that. And then we have to pull out the common factor. So negative 16 is already there, right? So common factor would be, we have x squared minus 4, and we have 2 of those, so I'll circle that so that I know that there's another one. So we have a quantity x squared minus 4. Right, what's left over would be x squared minus 4, so that's from the first term, so we take care of that. Alright, then we have a minus to 4x squared. So we're going to have a minus 4x squared. Alright, on the bottom you have x squared minus 4 to the 4th power. Alright, so we have a common factor, so you can cancel this guy and reduce the 4 to a 3rd power. And here, this is equal to negative 3x squared minus 4. Alright, so I'm going to just distribute this negative sign right here and turn those into a positive sign. So you're going to get 16, and then you have 3x squared plus 4 over x squared minus 4 cubed. Alright, So let's discuss concavity. So I'm going to draw a number line there. All right, so this function is not defined when x equals positive 2 or x equals negative 2 because that will make the denominator 0. So I'm going to put the negative 2 here and the positive 2. All right, then it's actually let's see. Actually, yeah, we need to put that. All right, then if you look at the second derivative, if you set this guy equal to 0, and you notice something that the numerator is never 0, so this guy is actually never 0. So all we have is a negative 2 and 2 for tick marks, right? All right, so let's check the sign. All right, so anything smaller than negative 2, so I'm going to try negative 3. So let's look at the second derivative. All right, so this expression numerator is always positive. So if you plug in negative 3 squared, so 9 minus 4 is positive. So everything is positive here. All right, if you try something like 0, if you plug in 0, top is positive, bottom is negative, so it's going to be negative. And if you try positive 3, you can see that the denominator is going to be positive, so everyone's positive, right? So we know that the original function f is going to be, right, so positive, so it's a concave upward on this interval, and the concave downward between negative 2 and positive 2, and the concave upward on 2 and on. All right, so let's type this guy in. All right, so concave upward was, let's see, I forgot, it's here, all the way to negative 2 to 2 and up. All right, so it's going to be negative infinity to negative 2 and union to and infinity. And a concave downward between negative 2 and a positive 2. All right, let's check the answer. Submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.